Hi, my name is Casey Walters, and I am in Miss Benzi's Quantitative Literacy class, and I am one of her amazing scholars, and I'm going to be going over Module 4 um, and the Excel report. Let me go ahead and share it with you. Okay, it is right here. And real quick, I want to go ahead and show you something real fast. I'm going to go over here to formulas. You'll see right here, everything looks normal. It's got the figures in it as it normally would after I did the calculations. But you'll go to show formulas, and it shows the formulas where, so you can actually see that I utilized the formulas and everything in Excel in order to get all of my answers. Once you use Excel, believe it or not, everything is so much faster and easier. Okay, so back to what we're doing. So like I said, we are on Module 4, and this is my Excel Zoom report, and we are on building blocks. So a worldwide poll of people wanting to move and those wanting to stay in the country they currently live in. We were asked to make a table and a pie chart of those who wanted to stay and those who wanted to move. We found that 29% of those surveyed wanted to stay in their country and 71% move. Some of the people surveyed said that they would like to move to a specific country. I found that 34% wanted to move to the United States, 10% wanted to move to Canada, and 10% wanted to move to the UK. I came up with these numbers by dividing 24 by 71 to find out how many people wanted to move to the US. And I did the same for each additional one. Now, I only divided by 71 because that was the number of those who wanted to move. Then to find the percent of people out of 1,000,000, I divided the percent of those who wanted to move to each country by the number of those who wanted to move, then multiplied that by 1,000,000. Then I was able to insert a bar chart to have a visual aid of that data. So here's my chart right here. And it shows the worldwide poll from 2008 to 2010. And these are the people who wanted to stay, and then the percentage, people that wanted to move, and then the total sample. And then I made this chart out of that table with my handy dandy Excel tools. And then right here, those wanting to move, United States, Canada, United Kingdom. And then I highlighted this and then made this bar chart out of that as requested, those wanting to move. And the great thing about these bar charts and graphs and everything else is it makes these, it makes it a lot easier to really see the difference between each category, the percentages. Anyway, number 2, the cost to take a taxi cab ride in my town is not bad at all. The initial price is $2 to start, then from there it increases by 75 cents per each additional mile driven. At no point did the graph cross the a-axis because you cannot measure distance in negative values. There's a steady rate of increase on the graph. However, the more miles you travel, the less the cost is. For example, for 4 miles, the cost is $5, and for 13 miles, the cost is $11.50. Since the initial cost to ride in a taxi cab is $2, that is where the graph crosses the axis, representing the cost, the y-axis. And so what I've done here is I have made a table, and then I used this table and made this bar chart, and then I also made this chart right here. Then number 3, if we were sales of a sneaker company. The discount sneaker company had a total initial investment of $240 to start the company. The company did not seem to lose too much because at the absolute lowest point, they were negative $304, which was only about $64 less than the original investment of $240. After hitting rock bottom, the company began to break, even after selling 13 pairs of sneakers. Then they started to turn a profit from there. Once they sold around 19 sneakers, they had a profit of over $500. If they continue on this path, they will have much success in their company's profit amount, and it'll just keep growing. So right here, I have this chart, and it represents these. Right here on the table is the amount of sneakers sold, and then right here is the profit, and of course it starts at 0 sold and $240 invested, so negative 240. And so at each point right here, I have it marked where it was at the lowest point, which was at having sold 4 sneakers, which I have right here. And then I also have it marked right here, which is where they had sold 13 pairs, and they were finally above negative, and that was at $20. And then at 19 pair, they had surpassed a profit of $500. And I have it marked, and that was at 19 pair. Number 4, I created a table and a graph to find the height in feet in time in seconds for if a pitcher threw a ball straight into the air. We needed to find the maximum height that the ball traveled and the point that it hit the ground. The maximum height the ball reached was 275 feet, and it took 4 seconds to reach that height. The ball hit the ground somewhere between the 8.24 and 8.245 seconds mark. I was able to calculate all of this using the function right here. And as you see, I put it in right here. So I was able to utilize the tools and the functions in Excel to get my answers. And as usual, Excel made this problem very easy for me to figure out, like I said. And that's how I was able to find my answers right here. Okay, and on number 5, at this resort in Costa Rica, the option that would allow you to stay for the least amount of money would be option 1. You could stay for 8 days and the cost would be $900. The option that would allow you to stay the longest would be option 3. This option would allow you to stay 17 days for $1,000. Wow, it's 9 more days for $100. Option 2 would be the least sensible option of all, because you could only stay for 4 days and the price would be $1,000. That's horrible. In order to figure out the cost of each of these options per day, we had to come up with different functions for each option. So in order to get the breakdown, here I made a table, and the first set, it is the resort in Costa Rica number of days, and it goes from 1 to 18. And then $200 first day decreases $25 each day. So that's option 1. And I've got a chart for each one. And then option 2, $300 first day, then subtract 10 times the square of the 8 days from the previous cost. And that's where I got these right here. And then the total's down at the bottom. And then $500 the first day, then half as much of the previous day. So literally for each additional day stayed, it was half the cost of the day before. It's pretty awesome. So anyway, what I did is I highlighted these, and then I went up here and I put chart, and that's how I got this chart right here. And you can see by the line the steady decrease in price. And then option 2 You can see by the chart that, by the graph that I charted each point each day and the cost and the decline. And then option 3 literally went from $500 to the first day, and then before you got to the 5th day, it was cents on the dollar. It's crazy. So, like I said, the option that would allow you to stay the longest would be option 3. This option would allow you to stay 17 days for $1,000 bucks. Sounds like a winner to me. Wish I had $1,000. Okay, so number 6. In this problem, I made a table and graph using the function for carbon dating formula. And that is this right here. That is the formula. It's fx equals a to the tune exponent, and then open parentheses, negative 0.0175x, close parentheses. And then I put that in right here, and then I let Excel do the work for me. So testing fossilized remains found in England for age is this chart right here, and it's years and century. If I know exactly how old the fossilized remains found in England were. According to my findings, the age of the remains were 461.61000 centuries old. Wow. This number was as close to 0.37% as I could get. Looking at the graph, it looks like there was a steady decline in the carbon, negative 14, up until around the 23%. From there, the amount of carbon stayed around the same without decaying very much at all for the next hundreds of centuries. Now, I was able to get this by magnifying percents in this table right here, and then I used those percentages, or those decimals, and turned them into percents over here. And then I kept it going over here. And this is the graph of the table, the graph of the table right here. And that's pretty much it. And as you can see, each one of these is getting easier and easier, and it's all thanks to Excel. So thank you, Ms. Benzi, for showing us how easy math really can be as long as you use your resources. Thank you, everyone. I hope that I've helped to explain how to use Excel, how to utilize our resources, and how to demonstrate how to get these answers within it. Have a great day. Thank you.